Imagine standing completely still in a forest of ancient conifers and ferns. The air is warm and thick. Somewhere behind you, hidden in the shadows, something is watching. You can't see it. You can't hear it. Not a single footstep, not a single branch breaking. And then the ground trembles. For 66 million years, we have been asking the wrong question about the animal that made that ground tremble. Not how large it was, not how fast, not even how it killed. The question that has quietly revolutionized paleontology, the one that keeps researchers awake at night, is far more intimate than any of those. What was it thinking? Was there something it was like to be a Tyrannosaurus rex? Did it experience the world, the smells, the sounds, the weight of a struggling animal between its jaws, as something? Did it recognize its own young? Did it remember? For most of the 20th century, those questions would have been dismissed as unscientific. Dinosaurs, the thinking went, were cold-blooded machines, animals running on pure instinct, with brains no more sophisticated than a modern reptile's. The image of the rex as a dim, lumbering predator was so deeply embedded in popular culture that it became almost impossible to question. And then the fossils started telling a different story. We are going back 68 million years, to a world of shallow inland seas, dense floodplains, and vast river deltas in what is now western North America, a region geologists call the Hell Creek Formation. A world already beginning to change, its climate destabilized by vast volcanic eruptions on the other side of the planet. A world that did not yet know what was coming.
In this world, at the very top of its food chain, lived the Tyrannosaurus rex. But to understand its mind, we need to understand what built that mind and how long it took to build. T-Rex did not appear suddenly. It was the product of over 100 million years of theropod evolution. And within the Tyrannosaur family tree, the fossil record shows a progressive trend, brain regions associated with sensory processing and complex behavior growing gradually larger generation by generation, until they reached their most extreme expression in Tyrannosaurus rex itself. To see what that means, we need to talk about a technique that has quietly transformed paleontology. When sediment fills an empty skull and hardens over millions of years, it creates a natural cast of the brain's outer surface, a structure called an endocast. By CT scanning fossil skulls and reconstructing these endocasts digitally, paleoneuroendologists can measure the relative size of different brain regions with remarkable precision. And what T-Rex's endocasts reveal is extraordinary. The olfactory bulbs, the brain regions devoted to processing smell, are, relative to overall brain size, among the largest ever recorded in any theropod dinosaur. In a 2008 study published in the Proceedings of the Royal Society B, paleontologist Darla Zielinskind and her colleagues found that the tyrannosaurs ranked at the extreme high end of olfactory ratio across more than 24 dinosaur species. The smell processing capability of T-Rex appears to have been, in relative terms, comparable to that of a modern turkey vulture, a bird capable of detecting a carcass from kilometers away. Think about what that means.
An animal the size of a school bus, navigating a forested floodplain, building a detailed chemical map of its environment in real time, tracking the location, the direction of movement, and possibly even the physiological state of other animals at distances that would seem impossible. But smell is only one piece of the picture, and the next piece surprised even the researchers who found it. For decades, T-Rex was assumed to have poor vision, a convenient assumption that matched the image of a dim, instinct-driven predator. That assumption collapsed in 2006, when paleontologist Kent Stevens published a study in the Journal of Vision using computer modeling to reconstruct the visual field of T-Rex from the orientation of its eye sockets. What he found was that T-Rex had a degree of binocular overlap, the zone where both eyes see the same object simultaneously, producing depth perception, that exceeded that of a modern hawk. Not a lizard, not a crocodile, a hawk.
Binocular vision of that caliber belongs to precision predators, animals that need to calculate exactly where a moving target will be in the next half second. And the eyes themselves were substantial. Bony rings preserved inside the socket of some specimens suggest eyeballs approximately 7 to 8 centimeters in diameter. The largest of any land animal alive today is 5 centimeters. T-Rex saw the world through eyes larger than those of any living land vertebrate. And it heard it differently too. CT scanning of the
Rex inner ear, pioneered by paleontologist Lawrence Whitmer at Ohio University, revealed a cochlea elongated in a way associated in modern animals with sensitivity to low-frequency sound, the kind of deep vibrations that travel through dense vegetation across large distances, exactly the acoustic environment of the Hell Creek floodplain. Some researchers have proposed that T-Rex may have communicated using low-frequency vocalizations, infrasound, the way modern crocodilians and elephants do. It's a hypothesis, not a certainty, but it's built on real anatomy, and it raises a question I find almost impossible to set aside. If T-Rex called to others of its kind, what did that sound like? If this investigation has you wanting to go further, subscribe now. Every expedition into prehistoric life reveals something unexpected. The next ones are extraordinary. For most of the last century, T-Rex was assumed to be strictly solitary. Then the bone beds started accumulating. At sites in Utah's Grand Staircase Escalante National Monument and at the Mother's Day Quarry in Montana, multiple tyrannosaur individuals of different age classes were found together in the same deposit, apparently killed by the same flooding event. In a 2021 paper in PeerJ, paleontologist Alan Titus and colleagues ascribed a Utah site containing at least 4 individuals, 1 adult, 2 subadults, 1 juvenile. Same place, same time. That pattern is difficult to explain if T-Rex was a strictly solitary animal. It suggests at minimum that the species tolerated proximity and raises the possibility of something more structured, family groups, cooperative behavior.
Other paleoneurologists argued that enlarged cerebral hemispheres don't automatically translate to primate-like cognition, and that without living relatives of equivalent brain structure to calibrate against, the comparison is difficult to sustain. The debate is unresolved. The conclusions remain contested. But here is what matters most about that controversy: the fact that it exists at all, that the fossil evidence is complex enough to produce it, that the straightforward dismissal of T-Rex as a simple, instinct-driven predator is no longer scientifically defensible, even if what replaces it is not yet clear. And perhaps that uncertainty is the most honest thing we can say. 66 million years ago, a Tyrannosaurus rex stood at the edge of a river in what would one day become Montana. It was reading the air with olfactory precision comparable to a vulture's. It was scanning its environment with eyes larger than any land animal carries today. It could hear frequencies that passed through the forest without decay. It may have recognized members of its own kind. And then, the sky changed. The asteroid did not discriminate. It did not choose. It arrived, and the world that had taken 100 million years to produce this particular answer to the question of what a large predator could be was gone. What remains is bone, and from that bone, scientists are slowly reconstructing not just what this animal looked like, but what it was like to be it, whether the word experience even applies. I find that one of the most extraordinary things science does, reaching across 66 million years toward the inner life of a creature utterly unlike ourselves.
But the attempt, careful, rigorous, humble, is itself worth something. The more I study these fossils, the more I believe that the true story of T-Rex is not the story of a monster. It is the story of a mind,
shaped by 100 million years of evolution, navigating a complex world with senses we are only beginning to understand. A story we are still, even now, just beginning to read. The investigation doesn't stop here, because there is another creature from the Cretaceous whose behavior, preserved in the fossil record in extraordinary detail, suggests a level of intelligence that still hasn't been fully explained. The real velociraptor, not the movie version. That investigation is waiting for you. I'll see you there.